Hi, boys and girls. Let's take a look at chapter or unit 3 in science, lesson 5. That will be on page 174. How is weather predicted? So we talked about that word prediction when we were talking about force. And we talked about a prediction being the interpretation of a pattern and using a pattern from the past to make a guess about what will happen in the future. Okay, so it is a guess. I mean, the weather guys who are predicting the weather, they are guessing, but they're guessing based on what's already happened. Either what happened this time last year in April, or predicting what happened with this particular storm yesterday, when it was in a different part of the country moving towards us. So it's all a prediction. It's not like they have a crystal ball to know what's coming. It's just a matter of looking at what has happened in the past, finding the pattern, and making a good educated guess about what's going to happen in the future. Okay, so page 174. How is weather predicted? So our science vocabulary is air mass, data, front, and meteorologist. Okay, on 174, weather affects everyone, everywhere on Earth. Can you predict the weather? Dark clouds may tell you it will rain, but weather is complicated. Scientists measure temperature, wind, and humidity. They look for patterns. These measurements can help us predict the weather. Page 175. Observing sky conditions. Suppose you see dark clouds forming overhead. What do you think the weather will be like? You can often predict weather by observing. One way to predict weather is by looking at the sky. On a sunny day without clouds, it will probably not rain. But watching clouds move, you can see the direction they're coming from. Knowing about some types of clouds can help you predict the weather. Cirrus clouds are thin, white, and high in the sky. They form in good weather. Nimbus clouds are thick, dark clouds that can bring precipitation. Cumulus clouds have a low, flat base and are white and puffy. They also form in good weather, but if a cumulus cloud grows very tall, it may bring thunderstorms. So that's something I didn't know, boys and girls. That's an interesting sentence. The very last one. If a cumulus cloud grows very tall, it may bring thunderstorms. I didn't know. Let's look at the captions that are by the pictures. You know what a caption is, right? This right here. All right, let's see what we have. At the top, it says this type of tall, flat-topped cumulus cloud could bring rain. So that's interesting. It's tall, it's way up there, but it's flat on top. The one at the bottom says, knowing about clouds can help people predict weather. Short, puffy cumulus clouds like these can form on a sunny day. All right, page 176. Describing air masses and fronts. You learned that air is always moving. Knowing how air moves can help predict weather. Air masses. Imagine a giant bubble of air floating above several states. If you could move around inside it, you would find that the air temperature is about the same wherever you go. So is the humidity. Air in the atmosphere is like this. A large body of air of the same temperature and humidity is an air mass. So, boys and girls, what is an air mass? Let's look back. Find it on your page. It's in green. Look at the words before it. An air mass is a large body of air of the same temperature and humidity. Okay? So, if our whole school is air, an air mass would be all of the third graders that are boys. So they're all the same, right? Now, maybe there would be something else that would be different parts that would include, let's say, like the boys and the girls. But think of this part. It says a large body of air, so a large group of children that are the same temperature, same humidity. Okay, same, all the same. That's an air mass. And remember we talked about how cold air falls and hot air rises? And we talked about how they don't mix. They go one on top of the other. Okay? So that makes you realize that different kinds of air don't necessarily like to mix with each other. So you can get a cold front and a warm front. The warm front's naturally going to go to the top. The cold front's naturally going to go to the bottom. Okay? But they're not going to intermingle. Okay? Air masses are described by where they form. Air masses that form over a cold ocean are cold. Air masses that form over a hot desert are hot and dry. Sorry, the cold ones are cold and humid. Okay, so if it's a cold front, that means it formed in a cold place. It started out cold. If it's a warm front, that means it started in a warm place, no matter where it ends up going. Because once in a while we can get weird temperatures and weather in the middle of winter, and we could get a warm front. Okay, and it could be that it started in a warm place and it just happened to come to us. Okay, so just because it's cold where we are doesn't mean that the front is cold. If it starts in a cold place, it's cold. If it starts in a warm place, it's warm. Knowing about air masses helps people predict weather. Suppose an air mass forms over a warm ocean and it moves over North America. It would bring warm, humid weather with it. Fronts. You may have heard someone say, a front is coming in. That usually means the weather is about to change. When one air mass meets another, they do not mix right away. Remember? They push against each other, and the line where those two meet is called the front. Fronts often bring weather changes. They are shown on the weather maps as blue or red lines. What do you think the blue one means? Cold front? And what do you think a red one means? A warm front. Knowing about fronts can help people predict weather. For example, a cold front is the edge of a cold air mass that is moving into a mass of warmer air. When a cold front meets a warm air mass, cold air moves. Does it move up or does it move down? Remember that story I told you with the balloon at the fireplace? Right? Okay. And think about how nice and cool your basement is in the summer. So if a warm front and a cold front come together, the cold air moves above or underneath. Remember, cold air goes down. The cold air moves underneath the warm air. Clouds and thunderstorms can form along that front. As the front passes, the wind changes directions. Once the new air mass is overhead, the skies may clear again, but temperatures will be cooler now. Okay, so boys and girls, remember the front is just where they're touching. Okay, because remember they come in and they don't do this, not right away. Okay, they're going to come in and they're going to kind of fight. Okay, eventually one's going to slide on top of the other. Okay, but it may happen something like this. You know, it's not necessarily like this. Air can be coming from any which direction, right? So wherever that happens is where you're going to get kind of that fight. Thunderstorms. All right. So page 178. Using weather technology. Weather can change from hour to hour, especially here in Michigan. Think of the snow and the sun, shorts weather, winter coat weather. It can change from place to place. Weather is very complicated. To make sense of it, scientists need to do more than observe the sky and weather maps. Collecting weather data. A meteorologist is a scientist who studies weather. Meteorologists collect weather data from many different places. Data are pieces of information, such as facts or measurements. Okay, so what is a meteorologist? First of all, a meteorologist is a scientist. Okay, we know ologist, right? I think we do. Didn't we study that? Ology, the study of. So a scientist who studies weather. So I wonder what that prefix meteor must have something to do with weather. We should look that up. So, and then what is data? Data is pieces of information. Okay? And it just depends on what are you learning about? That's the data you're going to have. If you're trying to figure out how big something is, your data might be measurements, inches, whatever. If you're studying how bears feed their babies, then your data might be observations of watching the bears. Okay? So it's just bits of information. Okay? Could be facts, could be measurements, all of those things. For example, if you wrote down the temperature, humidity, and wind speed, you would be recording data. Meteorologists collect these kinds of data at all times, but they don't take all the measurements themselves. This is done using weather stations. Weather stations have tools that observe and record data about weather automatically. They collect data on temperature and precipitation. They collect data on air masses and fronts. So boys and girls, you know how when you might catch the news and they say the weather service in Grand Rapids has declared a winter storm warning, and like maybe we're hoping for a snow day, right? Okay, well, what's happening is at this weather station in Grand Rapids, they're collecting data. They're figuring out the temperature changes. They're figuring out how much precipitation is coming. And in that case, the precipitation would be snow, right? They're looking at which way is the air blowing. Is it coming from where it's very snowy and cold, which is going to bring more cold weather? Is it coming from a warmer area? Okay, where's the front? Because remember, where those two air masses meet is where you're going to have your precipitation. So they would use all of that data to make a prediction that perhaps there's going to be a bad winter storm, or perhaps you should watch very closely for something like a tornado so that you're ready if it happens. Weather station locations, page 179. Thousands of weather stations are set up all over the world. There are stations on land and on ships at sea. People use computers to understand the data from weather stations to predict the weather. Weather is not just about the air near the ground. It is also about the air high up in the sky. So, meteorologists launch weather balloons. Weather balloons collect data about the air well above the Earth's surface. Tools on the weather balloon collect data about winds and temperatures. They send the data to weather stations. People launch some stations even higher up into space. These are called weather satellites. Weather satellites have tools that collect data about the atmosphere below them. The data are sent to computers on Earth. Scientists use all of this information to track and predict weather. Page 180. Using patterns to predict weather. Each night the sun sets. Each morning it rises. This is a pattern. There are patterns in weather too. Boys and girls, you know the patterns of weather in the seasons, right? Spring is cool, summer is warm, fall is cool or chilly, winter is cold. How cold? We don't know. How warm? We don't know. How much snow? How much rain? We don't know. But there's still a pattern there, right? Meteorologists study weather patterns to predict weather. Some patterns happen from day to day. It may be sunny every day for a week. Some patterns happen over a season. In parts of Florida, it rains almost every day between May and October. Patterns can be seen with air masses and fronts. A cold front usually brings storms and a drop in temperature. A warm front can also bring rain, but after the warm front goes through an area, the temperature is warmer. So boys and girls, if they see a front coming, remember we talked about how weather frequently comes from the Chicago area for Kalamazoo? Not always, but frequently. Well, if they see there's a front, there's two air masses that are meeting either above Lake Michigan or in Chicago, and they see that the winds are blowing it towards Michigan, then they can guess that that front is probably going to continue causing problems and will cause weather as it comes closer to Kalamazoo. Well, then they look at the pattern of what's the season, okay? If it's winter, then I don't think they're going to guess it's going to be a tornado. They're going to guess it's going to be a bunch of snow. If it's, let's say, May or October, and they see this front coming, and maybe it's a biggie, they might say, well, gosh, we better be prepared that there could be some severe weather like a tornado, okay? So if they see it coming, they can make these predictions based on what they've seen happen in the past. Patterns can be seen with air masses and fronts. Oh, sorry, I already read that. Scientists collect weather data from all over the world. The data are put into computers. They are used to make weather maps, graphs, and charts. Meteorologists also use weather data to make predictions called forecasts. And boys and girls, if you look at forecast and you break that up into the prefix and then the root or the suffix, for means ahead of time. So a forecast means to make a guess or a prediction ahead of time. So if you're forecasting the weather for next week, you're looking at the patterns and you're making an educated guess about what it will be for next week. Okay? If you're moving forward, right? You're looking ahead, you're moving ahead. What's another good word, Mr. Mandeville, with for? F-O-R-E. Like forward, forecast. Forward, no, I already said that. Format. I don't know about format. We'll have to think about that. We got a couple words that we can look up and understand their meaning a little bit better. All right, so boys and girls, go ahead and look at the Lesson 5 formative assessment page. Maybe you've even been filling that out as I've been talking and hitting pause. That's a great idea. Don't forget your page numbers. Remember, this is basically a study guide for when the test comes around. So really pay attention to these green words: meteorologist, data, weather station, air mass, front. That's why I put them on your paper, but that's also why I had you write in the page number so you'll know right where to go when it comes time to study those things. Okay? All right, I'll see you later.